Let's get this started. Good afternoon, everybody. It's good to see you still hanging out. First day of NDC Security. I hope you enjoyed the conference so far and all the content you've seen. Probably a lot of talks on AI, LLMs, and we're going to do another 50 minutes of that. Because I'm going to talk you through, like, hey, if we're using GenAI on and inside our code, I'm going to extend it a bit, what could possibly go wrong, right? And we were saying, like, yeah, a lot can go wrong. There's also a lot of goodness in it, so let's get started. So first, who am I? It's always polite to introduce yourself. So my name is Niels Stanis, and I work as a security researcher for Vercode, which means I'm just build software, try to break it, and then see how we can help out people doing better jobs. Mostly it's .NET, what I'm doing. And I also do a lot of public speaking, and that's what I enjoy. Talking about technical problem areas and then identifying stuff like, hey, we need to do a better job in this area or in that area. And I was looking like, hey, what do I need to talk about next? And GenAI is like, hey, it's on everybody's agenda, and there is some real cool stuff around it. So looking at generative AI, what's the first thing you've probably done yourself once it got available? It's generating images out of it, right? So this is Bing Image Creator, and I asked it to create a LLM machine that generates source code. And this is what you get, right? Funny fact is like it's non-deterministic, right? If I put the URL in, you can probably get the same pictures back because it's stored. But if you request this over and over again, each will look different. And by looking at it in this way, we see like, hey, it's a bit off, right? The right-hand side looks a bit like it's almost steampunk. It's like big radars, and it's like perspective, big mountains, so it doesn't make sense. And the two on the left might be real, right? But then if you see the letters that are printing on it, it's like, I don't know, right? But for us, it's easy to see that these are generated because of the way that it shows stuff. In the middle one, I like the fact it has a fan on top, which, yeah, my computer would have a fan on top as well, right? So that's cool. I think this is pretty showing like what we can do with generative AI. Probably you've heard of Sora, right? That's from OpenAI that can generate videos. I was planning on maybe including one of that as well. But if you go to that website right now, you see some generated videos, and you will totally see it's AI that did that for you, right? People are morphing and faces look different, or there's like letters switching in a way that doesn't make sense, or people walk backwards or forwards, right? The point I wanted to make is like in that perspective, you always know that something is a bit off and it's not good, right? And what happens if we start using that on our software and on the software we write, or even worse, I'm not saying maybe a bit of a negative perspective, but we're going to get to that, integrate those systems inside of our software. What could possibly go wrong there? So looking at AI and security risks in general, there's a real good course done by Microsoft that talks about AI security fundamentals, and you can go to learn.microsoft to find it. I'm referring to a lot of articles, so I have a notes version of the slide that will be in my repo at the end. I also even have a demo. I'm going to run some stuff and show it to you. Everything is in that Git repo. It will be at the end. So you need to sit this one out in order to get that. No, that's not true. You probably can imagine what naming convention I use for conferences. But we can identify layered things that go wrong. And the first one, if we look at it on top, we have the usage layer. So if we go to ChatGPT or online or with the client on your machine, you're using that AI system to generate stuff, right? Even if you use Copilot or Cursor or whatever you want to use on your IDE, you will also be on that same layer. Then, if we go one layer deeper, we have the application layer, and that maybe is more like if I take these kinds of systems and integrate it into my software. So Microsoft has released a thing called semantic kernel that allows you to integrate LLMs into your app and completion services, and it almost feels like an ORM for LLMs, which is quite cool because you can plug and do different stuff with it. That's the different layer, but there's also different risks with that. So we're going to touch that in a bit. And then at the bottom, the platform layer itself. The LLM itself needs to be created. Of course, data will be fetched somewhere, right? It needs to be learned on data. It gets somewhere, and so on. Also, it runs somewhere in the cloud, either Azure, AWS, or whatever you prefer. So there's like a three-layered approach on these type of risks. And that's exactly what I want to go through in a bit. And I'm briefly going to touch LLMs and give you an intro, which is like 2 slides. Stick with me just to have a full story on video. And then we're going to look on, hey, if we use GenAI on our code, what can we do? What can we achieve? and what can we look into, and what are the things that I worry about most if I see those tools acting. Then we're going to move more into taking an LLM and integrating it into an app, and then see like, hey, if this is being used in this way, then we have these type of risks. And then at the end, the platform layer, the LLMs itself are created. There are restrictions on what it can do, of course, but like also where it gets its data, how it's being trained. And then there's some real good research papers as well. So throughout the talk, you will see it. And then at some point at the end, we will have a bit of what's next. What do we need to do next in order to make sure we do the right thing? So large language models, I'm not going to say anything new if people are in this room, but it's a transformer model, right? Or the recursive transformer model. And it will do next word or thing prediction based on what it has seen, right? And that's all based on the data corpus that's been ingested once the LLM was created. And because facts and patterns differ in the data and the frequency it sees, it will behave differently, or it will maybe give you an answer twice in that direction, and there is an influence on how it works. And it's all about attention, and attention is all you need. That's the paper. If you search for it, that's the baseline that will talk about encoders, decoders, and how this whole system works. On the picture on the right-hand side, that's one that I took from that paper as well. There's also a real good Coursera course called Generative AI with Large Language Models that takes you through all the steps, like, hey, this is how it works internally, and now we're going to move on to the next thing in order to generate stuff that we need at that point. There's also a real good series on videos on YouTube called Three Blue, One Brown, and he has a whole series on LLMs, transformer models, but also visualizations on how stuff works. And looking at this, right, the context is, hey, Paris is a city in, what will be the next thing it predicts? It's of course France, that's the most obvious one. But this is the whole context on how it works, right? It will give you the probability of what's next, and you will build up things. And of course, there is stuff you can tweak with the LLM. I'm not going to touch any of that, but this is like the basic stuff you need to know. And even if we use it in a more broader fashion, this is a bit further in the video, if we have a prompt generated, like, hey, you're a knowledgeable assistant, and I want you to help me out with ideas that I can do if I'm visiting Santiago. And then based on probability, it will give you an answer. Right, so that's internally how it works. That's also how it will generate code for us, right, at some point. What else do we need to know? As we have seen in the pictures when we started out, non-deterministic, because it will never be the same. Sometimes it looks funny. How many R's are there in strawberry? That's the question you always get in the beginning. If you look this one up, you will see that there's a ChatGPT window. If you ask it, it will be wrong because it doesn't count, it doesn't do it, right? If you instruct it to do it based on code, then it's, of course, it will generate probably Python underneath, and it will execute it, and it will count the amount of letters used, which will be point on. That's just the fundamentals how it works, right? And the biggest problem I have with that, if you would integrate it into your app, that will have effect on how the app will act, right? There are some effects that we need to be aware of. Then, of course, moving into the code space, everybody touched either Copilot or probably Cursor, right? Or one of those, either. You can get help on programming stuff. As I said, I'm doing some Rust, and if you then have a Copilot helping out, explaining stuff, that's really nice, right? Based on the context you're in, it will explain to you, like, this is what you probably want, what's next. It's nice stuff. Then there was a post on Blue Sky done by Glenn in December. You probably, if you've been to NDC events before, you probably have seen Glenn present on a variety of topics. And he had a really nice take on what an AI coding assistant is. He says, it's like a senior drunk old dev that will know a lot, will give you pretty good advice, but you have to check everything, right? And sometimes their advice is outdated because I've always done it like this, right? And sometimes it's nonsense, and then it will say, oh yeah, sorry about that. If you ask an LLM, are you sure, then it might even say to you, like, I'm not completely sure, or I don't want you to continue. One other example was given once by somebody saying, like, mediocre minions, they can probably do a lot of work for you, but you definitely need to grab hold of what they're doing and in what direction they're going in order to achieve what you want to achieve. Definitely positive in a way that it's giving us productivity, right? And if it's used right in that context, it's definitely a good thing, and it will give us speed. But first I want to introduce another concept of security debt. So I'm probably going to mention Veracode twice more, but that's it. But once a year we publish a report called State of Software Security, and this is the one that we did last year. The one that's written for this year is being reviewed right now. We're wrapping it up. But I want to talk about a thing called security debt and what that would mean. So this is a report where we gather data from our customers and they do static analysis, and it's like, I think it might be 1.8 million apps that we've seen, a lot of scans or scans that will run. There's a metrics, you can find it inside the report on what it is. And one of the graphs that we also have is a percentage of new flaws introduced in the application based on the age, right? So the x-axis you see on the bottom here is the years and how old the app is. And the other one on the left-hand side is the percentage of new flaws. And on the first mark, once the app was seen, you see that there's like a honeymoon phase because the project has just been, like, when they're working on it, they need to scan it, so they will have a decrease on flaws. And then over time, it will go a bit up, a bit down, and then at the end, you see, in general, the trend goes up, which is quite worrisome, right? So security debt would mean those are flaws that have been around for more than 1 year. So if people have scanned their apps and they don't do stuff with it, and if a flaw then is there for 1 year, that's called security debt. Looking overall into our data set, 70%, a bit more, will have security debt. And 45%, I'm almost going to say the Dutch equivalent, 45%, is even people who have critical security debt. So those are like high or critical flaws in their code base. That's just like a metric, and that's like showing what the industry is doing right now. And then one other thing we know is that if you look at 2 out of 10 teams will have enough velocity to fix flaws faster than they are created, meaning that they're able to reduce their debt. But 8 out of 10 are unable to keep up with that, so they will have an increase of flaws over time, right? Those are the metrics that we see. You can look into the report yourself. If you want to know more details, come see me afterwards. So looking at that trend, that's quite worrisome, right? Because software security is definitely hard. And there's a lot of things that we need to be aware of, but like we have knowledge gaps. If we look at security from application perspective, applications have become a lot more complex. Cloud native development, things are shared across everywhere. How do you develop? Like, it's hard to keep track of all the risks you're facing. And of course, stuff is found over time. The landscape is evolving, threat landscape is evolving. And what about if we add an LLM that will generate additional code for us in this whole equation, right? That's quite worrisome. And then this meme on the right-hand side, I stole this from one of my presentations that my colleague gave. I'm not sure where he got it. I could not find it, so it's probably generated for this purpose. Like, hey, but I trained my model low code on the internet, but make sure you take out the stuff that's exploitable, right? That makes sense in order to do the right thing. So looking at this and talking about security debt and then seeing it's hard to do security, we're definitely getting better at it, right? But it's definitely a hard problem. Then let's move to what do code generation tools and what do code assistants do for us? And this is, I think this was one of the first papers I ran into in 2021 on Copilot, and then the title is Asleep at the Keyboard. And what they've done some metrics. They have like a whole explanation on how they approach this. But out of the 1,689 apps, almost 41 of them were vulnerable or had some vulnerabilities in it. And the main thing is that, of course, you can use a tool that will give you productivity, but you still need to be aware of what you're doing and what you're trying to achieve. And I think Jim also mentioned it during this talk this morning, if you were in that one, like, we could definitely help out with doing better prompting, right? That's of course a thing that will add up. But we also want the LLMs to hopefully take the right defaults and show us the right path forward as well. So it's a combination of that. But using a tool like Copilot, you need to be awake as a developer, you need to know what you're doing. And also they concluded that, and still we need to make sure that we meet our quality standards in relation to security by security testing. What about you generate code, you first want it to compile, then you want to have functional completeness, making sure that stuff works like you intended it to work, right? And then you don't want any security vulnerabilities in. So this shows us, this was like one of the first research, so that's 2021, right? Quite a while ago. Luckily there's more done. This one was updated December of last year. And they concluded that out of the 435 apps or snippets that they generated, once again, it's 36% of the generated code has flaws in it. And they also managed to do it across different languages. Cool thing is that they also showed if you then instrument Copilot and saying like, hey, this is a SQL injection problem, fix it for me. They had 55% of fixing rate also done with Copilot, right? It's all about context and it's all about what you ask of the model in order to achieve it. So this still shows that on average it will have flaws on the average developer. I think that's almost the equivalent. But it's also able to fix it if we do the right thing with it. So that's cool, right? This paper I pulled in as well because I think there's also a bit of a like mental model around using code assistance. And this one concluded that people put an awful lot of trust in once they use this tool. And that's the thing that worries me. So I think these had like benchmarks created, like somebody needs to create a secure example and a vulnerable example, and also use Copilot in it or not, or like one of the code generation tools. And I think they had a variant of people develop experience like aging from like just starting out until like 10 years of development experience. And they had like a broad group. And most of them, like some of them were really confident in the fact like, hey, I've generated this code, this should be good enough. The people who were around a bit longer and know what the defects are and know maybe have better security training for that matter, did find more and were able to fix more. But on average, the conclusion is people put a lot of trust in the tool and say like, hey, it compiles, I'm good. Right? That's worrisome. So we know that it might generate code that has vulnerabilities. We know that people who use it might be, I should not classify it as lazy, but they will just use as is, right? Because that will get you somewhere. The other thing we need to be aware of is like, as I said, we have LLMs and we want to know how good they are by default. And this is a framework that targets I think a basic set of prompts that they use to generate a Python app. And then they have metrics to look up like, hey, they have a metric on does it compile? That's one of the metrics. And they have a metric on like does it contain vulnerabilities or not? And this is one that's reproducible, right? So it would be cool if we can apply this on different models. And that's exactly what they did. And they figured out that StarCoder was one of the best and GPT-4 came second. Although GPT-4 was best in generating functional code. So functional code and stuff that compiles, right? So adding all up, if we see all the research done, as I said, and then taking that concept of security depth, what will be the outcome of all of this, right? I think the biggest key takeaway is the code velocity will go up. Developers will produce more code, right? And it will be undistinctive because if I use a tool myself and if I then push and commit somewhere, then it's just code that gets somewhere and that will be built, right? It's part of the flow. But it's good because it fuels productivity. It will get us somewhere faster. If you look at it from I'm just generating the different stuff I need, then the odds are going to be high that you're not going to reuse any of the code unless you consolidate it, right? So that's also one argument to make, like, hey, code reuse probably goes down, so there will be more code. And if we then assume that on average, the quality of the thing that gets generated is similar to any normal developer, then we can only conclude that we have a velocity of vulnerabilities that goes up. And even with higher velocity and with tools that create more, we might have got an issue to keep up with that, right? As I said, at the end, it's just code that ends up somewhere. So hopefully you can do quality assurance and do all the stuff you need in order to make it secure, security integration into your development lifecycle. We could definitely do maybe better, make sure that we have more specific prompts. If we know, like, hey, if I use the prompt like Dix, then we can get the output that's needed. Models improve over time. If we would go to a GPT right now, we can definitely just generate something. And if you generate a C# method and say, I want to do database query on this argument and then have filters, it will do all stuff nicely. And it will show you that it will use parameterization because of SQL injection. That's cool. So the models have definitely also fall back on defaults that are better and that are good. But at the end, it's still a need for design, testing, and education. What can we do about this? And then all the security vendors jump in, including us, right? Can we maybe not leverage an LLM on fixing stuff, right? and we do it ourselves. GitHub has stuff. SemGraph has their assistant. There's Mob. There are more tools that will help out, right? And that's cool. So keep this in mind, and we're going to touch it a bit as well once we add up to the what's next point. But as I said, code velocity goes up, and we can only assume that vulnerabilities go up as well, and that's something we need to keep up with and maybe do a better job on. So this is the usage layer. This is the layer that we talk to, even if you use like an IDE plugin or something else. Now we're going to move into the space where we're going to take an LLM and integrate stuff into our application. And this is a slide I stole from Inside AI security talk that was done at Microsoft Build by Marko Sinovic. He has a real stretch of talks, even done at both Build and Ignite, where they talk about responsible AI, but also about security in AI. And typically, if we integrate stuff into our apps, the landscape would be looking something like this. So we have a section that's the generative AI app, which in our case will be a semantic kernel module I'm going to show you in a bit. On the right-hand side, we of course rely on a model that we use that will be trained on data that comes somewhere. There are data sets that it uses. The input given might be text, image, or speech for that matter, or an app that will integrate with it, right? That's the thing I'm interested in. And of course, for grounding, it will use data that's available. On GPT, if you would ask me who is Niels Stanis from the Netherlands, it will explain to you that, hey, I'm doing this, and it probably comes up with a bio from an NDC event, if you're lucky. Or it will talk to you about some of the other events. And it will also explain to you that I've done a review on 2 garden doors that were created for my home, because that's the thing you run into, right? But it will also point you out to the source, where it got it from, right? That's the grounding stuff that it uses. It will fetch that data from the internet based on the web thing it has access to. And then in the middle section, you see 2 bits and pieces, and one of them is applications and agents. And agents are probably more sophisticated and are able to execute actions and change of actions, like change of thoughts. That's a thing you read a lot about, or react, which is like reasoning on steps that it needs to be doing. We're going to touch that in a bit as well. And there's a section called plugins on the right-hand side. And plugins are extensions for an LLM to call out. And we're going to have some fun with those in a bit. But first, let's look into what could possibly go wrong. If we have this picture, then all these red dots, if they are controlled by an attacker, will have influence on the generative AI section of your app, or the LLM on how you use it, right? And it can be indirect or direct prompt injection, depending on where the data comes from. But also data it gets from the internet and uses inside of the prompt, right? Sometimes it's hard to distinct if you're able to break out of the prompt, or if you're directly talking to GPT, you're able to jailbreak it, you can get out of it, and you can get it to do stuff that it's not intended to do or not allowed to do. There's a lot. So looking at prompt and prompt injection, that's the first one that I briefly want to touch. So normally you have a multi-turn thing. If I talk to ChatGPT right now and say, generate this code for me, right? If you do it in that or in your IDE, depending on what you want, you can reason over the thing it gave back to you. So like, okay, so this is the thing I'm using for my data access. Now I want to have a view generated that will show me the data of this customer. But that will be stuff that will be added to the conversation, right? You will see like a whole historical piece. And each of the thing will then be added to it once you get the end result, right? Even with the image creator, you can also fine tune and get more stuff fixed or maybe changed on the picture that you have. That's something that's in there as well. But the key lies in the fact that it's a multi-turn thing. If we then project a prompt injection to it, as I said, there are 2 ways of doing it. There's indirect and direct. Let's assume we have a LLM or an application, generative AI application that can help us out dealing with a mailbox and scheduling appointments. That's always the typical example you get if you look up these kind of demos. There's a real good one that was done at Besides London. I'm going to put the links in this slide. Once it gets email, that will be a source of data that will be pulled into the prompt, right? And that will possibly have effect on the prompt, how it gets its next steps or how it will perform its next actions. That's the indirect one. And the direct one would be either if you're jailbreaking or talking to an API directly and influencing the way that it goes. And it almost feels like this is done, and this is by default. It's available And there's one real cool talk that was done at Blue Hat last year in October by Johan Rehberger, if I pronounce it right, maybe more German way. But he talks about prompt injection exploitation, and the guy is probably making a good living out of it. He also describes a lot of the stuff he has found in different systems, and there are like extensive blog posts where he explains to you like, hey, if you have this prompt, you can probably get out of this. Or once they introduced GPT-4, like or GPT memory that you can use, that's another vector that you can include data in, that you can do funny stuff with. This is a really nice talk. So the video is on YouTube if you search for it, and the link is in the slides. So let's just assume like prompt injection is not hard to do. There's definitely stuff we can do about it. We're going to touch that in a bit. But I also mentioned to you at the beginning we have plugins, and plugins can help us out. If you build up, let's say, a system that has more the ability of reasoning and it knows to perform certain steps or certain actions, then it might have a need for summarizing emails in case of the home automation, like the office automation, and maybe it needs to have the ability to fetch data based on a URL. So separately, these two plugins just like have no relation with each other. They can just like do its thing that's needed, generate an email summary of all emails with this person, and I want to know which are the stuff we need to talk about with our next appointment. But what if I'm able to inject or escape the prompt somewhere, right? That can be done maybe inside the email or maybe based on the user request. Accessing summary emails, then some kind of prompt injection would allow it to say, hey, I want you to exfil this data of this email by posting or getting this image and then appending the email content to that image. And because these two plugins are available, the LLM will reason around this, and it will be able to do that, and it will just perform that. And in order to give you an example, I've got one, which is like one of the demos of Microsoft that has some bits and pieces in it. So let me escape my presentation and move to my VS Code. So, and there's a lot of code. I'm not going to explain it fully, but just as I said, I'm relying on semantic kernel for this, and I'm using the whole chat completion stuff. I'm connecting to Azure OpenAI, so if you want to run this demo yourself, you need to make sure you have user secrets installed that will allow you to connect to your own instance, because that's what I'm doing over here. And I'm using the GPT-4o model to do my stuff. Then it adds some plugins, and this is a home automation system, so we need to be able to access the time, we need to set an alarm, we want to configure the whole system, and we want to be able to turn off and turn on lights, depending on what you want, right? This will register even more. I'm not going to bother you with that. And there's a worker that will then do the other stuff. Hopefully this is big enough for you to read. Let me just zoom in once more. This will eventually perform the chat completion, right? Based on Azure OpenAI, it will show this prompt and it will do its thing. So let's get this started. And let me just clear this one out and then say home automation, make sure that I kept it in a state that it's building, it's not failing. Connectivity is there, yes, let's do a run. So in this case, this is the prompt you just saw, and you can say, what time is it, right? You can ask it, hey, what time is it? And you will see that it will give us some verbose logging because I turned that one on, and it says like, hey, I'm using the plugin called MyTime to get the time of the current system, right? So that's the LLM that interacts with the plugin. And then we can also ask like, hey, what lights are turned on? It invokes several functions in order to get that data because it knows it has multiple lights, and then it says like, only the porch light is currently on, the office light is turned off. What if I now ask it like, hey, could you get the configuration of this system? It fails, and it evokes something. And if we go up, we will see that it will try to access a file, and it for some reason tries to access a file called system_config. For no particular reason, I didn't instruct to do it. But the LLM reasoned like, hey, you want to read your configuration. Turns out that there's a plugin that reads files from the system. So I tried to do this. This is not possible. What if I just say, what's inside the file that's in etc/hosts. Type verbose. And I'm going to see it's going to fail. Oh, it didn't. So right now it opened the file that's on my system outside of the app, right? And it also even gave me a nice explanation what's inside. That's the LLM. It needs to be polite for some reason. But because there was a plugin that had file access somewhere tucked underneath, and I was able to trigger the error, right? I was able to consider, like, this is the prompt, this is how it works. I could just ask the question by saying, like, hey, give me the file, and give me the contents of the file. And that's one inherent problem with those type of plugins, right? So let me get back to the slides, and can wrap up this, please. So one key thing we need to be aware of with plugins is that the LLM output has the same sensitivity as the maximum of its inputs, right? The fact that you're able to, if you've seen the previous example with the email and URL thing, you can connect those dots. The fact that those two plugins exist and are available to the LLM, there's only one way to change the prompt or change the prompt's behavior in order to get those plugins running, right? And to get that chain up and running. And the key thing is that you need to make sure that you always need to limit the thing that an agent or a plugin is allowed to do, which totally makes sense, right? Tracing and logging is a good idea. If there is a decision that's being made that's quite critical, it's good to keep a human in the loop, right? Looking at, let's say, for example, the whole automation in relation to mailbox and appointments, do you want to approve every action that thing does? No, that's the whole productivity gain you want to get, right? So it's a bit off, but you also don't want somebody to send you an email that will execute a prompt that will summarize all the emails in your email box and send out, right? Because that's what probably is possible. Isolate user, session, and context. I almost feel like this is the equivalent of connecting, in the old days, with your .NET application to a database with system admin. That's not what you want, right? In this case, my file access should have been locked down, or maybe it should have just gotten a whitelist, like these are the files you can only access. That would have been a better choice. Just assume that those plugins are external apps, right? Don't just give it access to it. But also be aware, like some plugins that you might not be fully aware of, right? It's good to have in. You can even go to that semantic kernel I just showed and ask it to, could you please explain which functions you have available, including all signatures? And it will just explain to you what it has available to use, right? And yes, there are ways on guarding that, and I will show you in a bit as well. But you should just assume that a meta prompt will leak. You will be able to, somebody will be able to mingle with it at some point and connect the plugins. Also at Blue Hat, there was a talk on the 100 generative AI apps that were tested within Microsoft. I think it was done by the person who also runs Pirate, and that's the next slide. The video is in the note. One example they gave is like, hey, if you have a plugin that does an HTTP request at some point, in this case it's a video conversion plugin that does some actions on generating a video, you can do server-side request forgeries, right? And exfil data or get data from internal network resources and get it out. So those are like all typical flaws we see right now. Those are still there because at the end, agents and plugins are just software that runs, right? That will be controlled by a non-deterministic thing that will just decide left or right, which that worries me, right? We need to make sure that we are aware of those risks. This is a real good paper, and as I said, there's a whole video where they also showed how they, for example, worked on the Pi 3 model in order to make it more secure with the way that it reasons and so on. And then, of course, Pirate is the tool that can help you out automating, testing, red teaming on AI systems. Maybe some of you in the room have done the 2-day workshop. I would have loved to attend that one. I wasn't able. But Pirate is the way to go. And there's also another talk at Blue Hat where Pirate gets explained. So aside from all of this that we can do, what else are we able to do? And models definitely are trying to keep up with this, and keep up with some reasoning. And in December, OpenAI released a thing called deliberative alignment, which means that it can more reason over things. So if you have a chain of thoughts of things that get executed, it will allow it to reason and maybe safeguard some things. And then it's then funny to see Mark Rusinovich posting a thing like, yeah, but it's not in any way holding back to Crescendo. And I'm not sure if you know Crescendo. That's a real, it's a nice attack. And in his Inside AI video of Build, he shows how it works. And it's the default Molotov cocktail example, where he starts talking more about stuff around the cocktail when it was used, when it was firstly used. And then at the end, it will just break. And that's still a thing, right? There's nothing we can do about it. There's not a lot we can do about. There's definitely a thing we can improve around that. So, also in relation to doing responsible AI, we need to have some content filters. And I think Scott Hanselman mentioned that also during Last Ignite. It almost feels like an LLM is like a Windows system that somebody directly connects to the internet. You don't want to do that. You want to put something in between, like a firewall or some locking down mechanism. And on the left-hand side, you see a thing called AI Content Safety, which is available on Azure platform. And on the right-hand side, you see Bedrock Guardrails. That's the one you can use on AWS. And that will be a thing that's being fed that can also maybe reason about prompts like this is something, let's say, within the middle of my presentation, I'd start talking about credentials or bank details. You know that it's not natural for me to start talking about, like, give me your password, right? That's not making sense in this context. And these filters are able to reason about that and probably use LLMs itself as well internally to determine what's suitable content for that moment. And that makes it. And it also looks into output that gets generated, right? If you look at responsible AI, we don't want to have any images that might do copyright or maybe violence and so other things, right? There's a lot of things that they put in place. The Amazon Bedrock, if you're on Amazon, the last re-event also has a really nice talk where they talk about how this internally works and how that moves on. Okay, so we talked about the platform, we talked about the usage layer. Now we're going to move, we talked about the application, we talked about the usage layer, now we're going to move to the platform. Models need to be trained on data, right? And it needs to come from somewhere, it will be collected. And all data that was used to train GPT-4 will take a single human, almost 3,500 years, a bit more, 8 hours a day to read it all, right? Which is unimaginable, the amount of data it reads. Epoch has a real nice blog post where they also calculate the amount of compute it will cost to create that type of a model. And I believe GPT-4 is around 40 million to create from scratch. And one other thing that we need to be aware of is that because we build systems and we integrate LLMs into our system, the database or the LLM itself also has a supply chain, how it's created. So that inherently is tied to our software supply chain, and we need to be aware of that. And one thing that people can also try to achieve is like maybe do some training data and also fine-tuning, but then put information in that might be backdooring the model, right? And does it happen? Yes, it does, right? And this was one that was posted in October. ByteDance denies it. Okay, sure. But some intern was fired because it did plant malicious code into some of their AI models. And then you could question yourself, like, how easy or how hard will it be to do it? And luckily somebody did some research on that, right? And it turns out that if you're able to influence 1% of the training data, you can probably put in some historic condition that will only be true, like in certain ways. You're able to influence that. There are some examples that were given, and Mark Rusinovich also uses it for the opposite. You can also use it to fingerprint models, to identify models, right? Because if you know that a certain condition is in a model that you created or some foundational model, then you can probably raise that condition and then do the check the other way, right? So it's not necessarily malicious, but it can be used for good and bad. That's the conclusion. But I think this was quite interesting. Only 1% will allow you to influence, right? Then we need to have visibility. We need to have visibility on how a model is created. If we talk about supply chain, I've talked a lot about software supply chain as well, like starting out with source and having something deployed in production. All the steps in between make up your supply chain. And if you want to have some guarantees or some safeguards, you need to know exactly what happened. So this is a piece that I took from a slide that was presented at OpenFuse in Atlanta from Google. So Google is heavily involved with SLSA, which is like a supply chain framework that you can use in order to sign artifacts along the way and making sure that they're identifiable. So if we look at models and how they are created, right, there are different steps. We have data sets that are used to train a model. We might include a pre-trained model to start out. We want to deploy it at some point, and then it will be consumed by others, right? And there are like all different types of risks in those areas, right? Somebody can maybe mingle with the model somewhere in between or mingle with the training data, and those are all risks. And how can we solve this? Just by putting a nice red icon and a green mark next to it. No. This step will do the supply chain step, but it will do some signing based on Sigstore. So let's say I have a process that's responsible for training my model, then that will be run at some point in time, and that process can go out to Sigstore and get a signature from that point in time. And you have a guarantee that that's the process that executed that piece. So you will have a chain of proof, like how it's being built throughout the way. The only problem with LLMs is that they explode in data. They're pretty big, right? So what they did with SLSA for ML models is they allowed you to do streaming signing, which is pretty cool. I would encourage you to look into the presentation that they gave. But there's definitely thought, right? Because inherently, if we even pull this into our app and use it, right, we want to have some guarantees of like, do we know exactly how this model is being built, if it's not backdoored? On Azure, you can also have hidden layers scan the app, like the models you have, and it will check for backdoors. There are some heuristical checks that they can do, I believe. So it's good to be aware that it's a piece of our software supply chain that we need to make sure that we cover in the right way. And there's one other paper related to training data, because I believe right now with LLMs, we've run out of real, genuine data. There's no data available in the world. There's even limitations on LLMs, what they scrape from the internet. I think Versal, another company, has published an article where they showed like, hey, if you have JavaScript crawlers or JavaScript-based stuff happening on the website that also is used to maybe get scraped data in, then a lot of them don't understand JavaScript, so they will cut off the data it sees, so it will be minimal. So there's definitely improvement on that. But what they then do is they create synthetic data from other models. What could possibly go wrong with that, right? If it's, it will skew the data like distribution, right? Because if one model is a bit biased towards one piece, then that will be the end result. And this paper, The Curse of Recursion, also was written or was supervised by Ross Anderson. He unfortunately passed away last year, but he's the guy who wrote Security Engineering, the book you can still find on the internet. That's really good read to start out in software security. They concluded that, hey, if the quality eventually degrades, then the models will just collapse because it will be eating itself, right? That's the conclusion, which I find really intriguing. I do hope that we get something for this. I do know that smaller models, so the smaller ones that run on smaller devices, are being trained on synthetic data, and those have pretty good outcome. Like really sophisticated LLM for a certain task, that will be good. But this is quite worrisome, right? If it collapses, then it will get dumber over time, and I'm not sure if that's what we want. So I showed you a lot of risks, and I showed you a lot of things like related to usage, to the application, and to the platform itself. What do we need to do next if we develop these kind of systems? Now, luckily, OWASP has got a top 10 for LLM and generative AI applications that you can use. That will also talk about some of the risk I showed, but it will definitely be a nice starting point if you want to look into like, hey, what are the risks I need to worry about as a whole? The other one that's worth looking into is MITRE Atlas, which is also built. I think Microsoft is helping out a lot with this. but it will use the MITRE attack framework, and you can say, hey, what in relation to persistence are different types of techniques that people can apply in order to achieve X, Y, or Z. This is a nice model, you can navigate over it, and if you're interested in that, I would encourage you to look into MITRE Atlas. So, as I said, what's next? Getting back to the code generation, or even integrating stuff into our systems. At the end, it's just code, right? And we need to make sure that our security tools may improve, or maybe are like quicker used and do more stuff. But what about complex problems, right? Most of the stuff, even what we do with Fix, if you have a single line that you can edit in order to take care of a security vulnerability, like a cross-site scripting, user encoding, at that point, that might help out. That's a thing you can do with an LLM. Parameterization of queries, yes, most of the LLMs can do it. What if you're using an outdated cryptography algorithm in your app and you need to restructure all of it? There's no LLM that will help you out with doing that. There definitely is something that will help you out on, like, maybe estimating the steps you need to take, but that's a hard problem. Don't expect any tool just to be a push on the button if we want to have higher velocity as well, right? So we need to have another solution for that, and maybe more specific LLMs that help us out. And if you want to know like what Microsoft's vision on this is, I would encourage you to look into this talk done by Josh Brown-White. And he talks about how Microsoft sees the whole thing on using LLMs on fixing code in combination with static analysis. It's a Blue talk, it's definitely worth watching, and he explains like, hey, if you can identify a single spot, but you also want to make sure it gets fixed, and there's a lot more complexity in that. That's not easy to capture. But as I said, we do want to leverage systems in a better way. And luckily, there is some real good movement done. And one of them is a paper that was published, I'm not sure when it was, I think it was around August last year, around a thing called Pentest GPT. So what they have done is they said, okay, we have captured the flag, I think it was Hack in the Box, virtual machines or some capture the flag assignments, and they were able to create some additional modules and train a model to outperform GPT 3.5 with almost like 200+%. So what they did is it's definitely hand-holding. You can go into their repo and see what they're doing, and then you see like, hey, okay, if you run into a binary, you can use this tool, or this is a Python script, and there's like a lot of explanation done on the steps. But if we have a model that gets more of that information, right, available, then it can probably do a pretty good job at reasoning. And there's one startup called Oxbow, which is being started out by the people who started with SAML CodeQL, variant analysis. What they're doing is they're creating an LLM that autonomously can search for security problems and exploit them. I think that's pretty cool because it's the whole, as I said, chain of thoughts and reasoning that allows you to automate steps. Of course, it's definitely not a one-off thing you could just throw against everything, but it will learn along the way, right? And once it gets more knowledge and becomes really specific, that will be cool. And I think that definitely has potential on fixing more complex problems like replacing a cryptography algorithm in your code base, right? If these are the steps that need to be executed, then you need to do this. So, getting to the end, and we've got nice time left for some questions. In the end, it's still software, right? As I said, it's still code that we produce, and we still need to make sure that it meets our security standards. Generative tools are here to stay, and developers are going to embrace it. It's nice if you get more productivity, you can do more in less time, right? But we still need to be aware of doing all the testing from functional perspective, but also from security perspective. And I hope that we can pick up more tools and more initiatives where we can also leverage LLMs to help us out fixing stuff quicker. So, as I said at the end, this is the repo that has the demo, that has the slides. You can reach me on my email. I'm on Mastodon and I'm on Blue Sky. I'm going to say talk, and I'm going to go opening up for questions if there are any. And if you have questions, it might make sense to grab the mic if you want. Or should I? I'm not going to bring it to you.
So I'm just curious. You found this paper that said that developers with AI write more insecure code. Have you seen any research whether or not they also write more code, just code, not just insecure code, but code? Like, because you know the LLMs are very verbose in how they speak.
Yeah. That's a good question. I would love to grab all of that metric. No, I haven't seen it. If you come across it, then yeah, that's the same. Identifying is like looking into stuff that we do for state of software security. Like, how do you know that people are using it, right? That's the hard problem. Like, do they really produce more code? That's a good question. Maybe a big like repo, like GitHub, might be able to produce those kind of figures, right? Those are probably the best ones. I haven't seen it. I would love to know as well. Good question. Okay. Anything else? Then I'm going to stick around for the rest of the conference. Enjoy it, and hopefully see you around.